Hello, students. Welcome to the platform of True Tutors. Myself, Birendra Yadav, and I welcome you all for today's discussion. Students, this will be a demo class for all those students who are planning to opt geography as their optional in 26 and 27. Students, before beginning, a very brief introduction about myself. Myself, Birendra Yadav. I'm a faculty of geography, and in my UPC journey, I have given three mains with two interviews and have scored more than 300 marks in my optionals. Students, in today's class, I will be discussing a very important concepts in geography just to give you an idea how I conduct my classes, how I teach. That will help you to understand my pedagogy skills. And if you're trying to, if you're planning to offer geography in 26 or 27, you can join us in my personalized mentorship program. So, student, let's begin with today's discussion. Today, I have brought in a very important concepts from geography. In today's class, I'll be telling you what is latent heat. Firstly, we will discuss this. Thereafter, students, I will tell you what is lapse rate. And in today's class only, I will also tell you why there exists a lapse rate in the atmosphere. And lastly, students, we will see the types of lapse rate. Let's name lapse rate as LR. Student, I have brought in the latent heat concept in today's class because in order to understand today's class better, you will need to understand what is latent heat first. Okay, so we will begin from here with latent heat, and thereafter we'll come to the lapse rate, why there exists a lapse rate, and what are the types. Students, very briefly, our agenda will be mainly centered around understanding lapse rate and its types. But in order to understand lapse rate better, you need to understand what is latent heat first. Student, latent heat is nothing but a heat which is required to change a phase of a substance. Okay, so let's take example of water. Let's take the example of water. For better understanding, let's consider this is ice, water, and vapor, water vapor. Okay, students. So latent heat is nothing but a heat that is required to change the state of an phase of an substance. So for better understanding, we have taken the example of ice, water, and vapor. We know that this is all forms of water only. Okay. So when a ice is converted into water, the ice is co- converted into water. Here, heat of fusion is required. I am naming only fusion for simplicity. Ice into water, heat will be required for ice to convert into water, and that is known as heat of fusion. Now, from water to convert into water vapor, heat is again required, and that is heat of vaporization. Now we know that water vapor can also convert into water again. See, student, here heat is required. So I am mentioning that with an positive sign, with an addition sign. Okay. Here also heat is required for water to convert into vapor. So again, I am indicating that by a addition sign. Now, for water to convert into vapor, to convert into water again, here things will change. How? Here there will be a release of heat of condensation. Heat of condensation. Now you must be thinking about that, sir. Why you mentioned that there is a when there is a phase change, the heat required is an latent heat. Why you must be thinking about, sir, heat is also absorbed to change the temperature of a substance. Why there is a phase change? Student, for better understanding, let's think about this example. When you boil water, when you boil water and you boil the water up to the temperature of 100 degrees Celsius, you know that after 100, after heating water up to 100, when you start to boil water, when once the 100-degree temperature is reached, the water then starts to evaporate. The water cannot hold much heat than 100 degrees Celsius, and it starts to evaporate. Okay, and we also know that the heat of the temperature of the steam, this temperature of water vapor, or you call it steam, is greater than boiling water. So the extra heat, suppose if you're boiling water and once the 100-degree temperature is reached, the water start to convert into steam. So the if you keep heating the water even after 100 degrees Celsius, the temperature will never reach 101 degrees Celsius. Only phase change will take place. So the extra heat which you are supplying is used for water to convert into water vapor, and that is the latent heat which is taken by the water to convert into vapor. Okay, and when this vapor is converted into water again, there is a release of heat, and that is the heat of condensation. Now, student, this is important when we study adiabatic lapse rate. Now, for now, only understand what is latent heat. I am sure you must have understood it by now. When ice converts into water, there is an absorption of heat. And when water converts into vapor, even if you suppose, if you freeze the water further, even here there will be release of heat, heat of condensation. Again, there will be release of heat of condensation. So here there is an addition, here there is an giving away of heat. And this heat of condensation, students, is important for understanding adiabatic lapse rate. So understand for now what is latent heat. Latent heat in very simplest term is nothing but a heat which is required to change a phase of a substance. When there is a phase change, the heat is absorbed by the atoms to change its phase. That is the latent heat, and it is different from the external heat, the specific heat which we feel on our body. It's different from that. Latent heat is only related with phase change of a substance. And this is the example which I have given you here. Now, students, let's come to the main topic of today's demo class, and that is the lapse rate. Student, for this is lapse rate, which is also known as environmental lapse rate or normal lapse rate. Student, lapse rate is for a normal condition. The lapse rate is nothing but 6 degrees Celsius per 1000 meters. Now you will ask me, sir, why there exists a lapse rate? This can also be a question in UPSC because lately they have been asking more conceptual questions. Okay, for better understanding of what is lapse rate, first we will need to understand how the atmosphere heats up. So lapse rate is nothing but, as for better understanding of lapse rate, let's consider this is the ground level. This is our sun. Okay, and students, this is ground level. The the first layer of atmosphere above us is, you know that it is troposphere. You know that troposphere is very important for geographers and weather climate experts. Why? Because most of the climatic events take place in the troposphere. Above troposphere, we know that we have a layer of stratosphere. Okay, above stratosphere there is mesosphere, and above that there is thermosphere. Very briefly, student, I'm giving you some extra knowledge just to clear your concepts here in the class itself. So in troposphere, you must be knowing that there is a fall of temperature. As you move up in the troposphere, there will be a fall of temperature. I will explain why there exists a fall, but let's first understand why what happens in the upper atmosphere. In troposphere, there is a fall of temperature. In stratosphere, there is a rise of temperature. Okay, and again in the mesosphere, there is a fall. So I am indicating with plus and the subtraction sign here for simplicity. And thereafter, in thermosphere, again there is a rise. Now you will ask me, sir, why this happens? This mainly happens because I will explain in a bit. But firstly, let's understand in troposphere. In troposphere, there is a fall. In troposphere, there is a rise. The rise is mainly because of the ozone layer here. In the troposphere, the rise is mainly because of the ozone layer. And in troposphere, again there is a fall. And in thermosphere, there is again a rise because of the presence of ionosphere here. Okay. Now, when we talk about students, when we talk about lapse rate, we are mainly concerned about the troposphere because we know that most of the climatic events take place in the troposphere. The formation of clouds, hails, hailstorm, rains, everything that take place mainly in the troposphere. So when we talk about lapse rate, we are mainly concerned about troposphere in general. So students, in order to understand why there exists a fall of temperature of 6 degrees Celsius per 1000 meter in the troposphere. For that to understand, let's consider this is sun, this is our ground surface. This is ground surface where we are living here on the surface of the earth. So when the sunlights enter our, we know that the life on the earth is regulated by sunlight only, sun radiation. Everything is connected to sun radiation itself. We know that. So when the sun radiates, when the sunlight enters our atmosphere, it comes in the form of the sunlight. When it enters atmosphere, it comes in the form of short wave radiations. Short wave radiation is nothing but the wavelength is smaller here. So when it enters our atmosphere, their wavelength is smaller. So they come on a hit on the ground surface. And when they come on hit on the ground surface, it is reflected back in the atmosphere. So when they enter, when they enter, when they enter, remember this students, this is all important concept. When they enter in the form of shortwave radiation. And once they hit on the ground surface, they are reflected back in the form of long wave radiation. Long wave radiation. They hit on the ground surface and they're reflected back in the form of long wave radiation. And this radiation is also known as terrestrial radiation. Okay. I hope this much is clear. Sun rays enters. When the sun rays are of short wave radiation, the atmosphere acts almost transparent to them. The atmosphere is almost transparent to them. They come on and hit on the ground surface, then reflected back in the form of terrestrial radiation. So terrestrial radiation is this is long wave radiation. So when by this long wave radiation, the atmosphere starts to heat up in the atmosphere. The atmosphere start in the troposphere. The atmosphere starts to hit by this long wave radiation. So the temperature is higher at the closest level of the ground surface and it falls with rising altitude. So there in normal condition there exists a fall of temperature of 6 degrees Celsius by 1000 meter. If you go, the heat will start, the atmosphere will start to heat up above the ground surface. You you must have experienced this when on a sunny day, when we talk on the pavements, when you are walking on the pavement, you must be feeling very hot air on your legs. as comparison to your head or your body, other parts of the body. That is because the temperature is higher on the lowest level and it falls with rising height. So you feel that the you can feel the hotter air on your legs as comparison to other parts of your body. So why is that? Because the atmosphere is the hotter at the level closer to the ground surface. That is only the reason. Okay, students. So as mentioned that sun when it enters short wave radiations almost transparent to them, they hit and they are reflected in form of long wave radiation, and this is called also called as terrestrial radiation. So for this reason, student, this is one of the reason why the temperature is falling as you move in the atmosphere. Now, student, let's understand why there exists a lapse rate. Why there exists lapse rate? The first reason is I've already told you in the past slide. That is the because of the terrestrial radiation. Now, terrestrial radiation we have seen here. What could be another reason? Just think about it. The other reason is presence of water vapor and CO2. This could be because of anthropologic and non-anthropologic or natural reasons also. Anthropologic is nothing but man-made reason, or there can be a natural reasons also. For the concentration of water vapor and CO2 in the lower level is the highest. We know that currently we in our times world over we are facing the challenge of climate change. That is because of rising CO2. So CO2 is rising. Even we know that the planet Earth is a green planet. There are plants here, there are water bodies here. So when the sunlight falls on them, the water is converted into vapor, and the water vapor and CO2, they are higher in concentration at the lower atmospheric level. Here in the troposphere, in the lower level, the CO2 and water vapor is the highest. So these are nothing but, student, you must be knowing this, that these are greenhouse gases. These are nothing but greenhouse gases, and the important character of greenhouse gases is that they absorb heat. Okay, students. So now water vapor, CO2 is higher in the lower level of the troposphere. They absorb heat, and that is the reason why the temperature is higher at the lower level and it falls with increasing height. Due to one reason is, as I told you, that the atmosphere is heated up by the air closer to the ground surface, and second reason is due to that the concentration of water vapor and CO2 is highest in the lower levels. This is the another important reason. So, student, I think so far we have discussed what is latent heat, what is lapse rate, what is normal lapse rate, what is environmental lapse rate, why there exists a lapse rate in the atmosphere. And when we talk about lapse rate, we are mainly concerned about the troposphere, where major of the climatic events take place. Now, let's move on to a very important concept. Very important concept. I have seen that students face problem to understand the basic concepts, which hurt their marks in prelims and mains and also in the optionals. So now the last topic of the day, students, that is adiabatic lapse rate. As I mentioned it before, as I mentioned it before, for understanding of adiabatic lapse rate, we need to understand what is heat of condensation. We have already discussed in the past in the first slide. Now, just have a brief recap about it. Heat of condensation is nothing but latent heat is nothing but latent heat. We have discussed here latent heat. Latent heat is nothing but the phase change. When there is a phase change, latent heat is absorbed or released. Okay, and also in latent heat, when water is converted from water vapor to water, when water vapor converts from water vapor to water, there is a release of latent heat of condensation. And when water converts from liquid to ice, there are also release of latent heat of condensation. So in adiabatic lapse students, will be we need to understand what is latent heat, which I've already discussed. Now let's come to the adiabatic lapse rate. For better understanding of the labs, adiabatic lapse rate, students, let's consider this is a column of air. This is a column of air, and this is outer atmosphere. Okay, this is a column of air. Student, now consider. Let's we can also call it a system. Let's name it a system, column of air or system. Okay. Now, in what is adiabatic? In a adiabatic system, the basic fundamental concept of adiabatic is nothing but when in a system, when there is no heat entering the system or leaving a system, and all the heat changes are internal only. That means no heat enters, heat, no heat enters, no heat leaves the system. No heat enters, no heat leaves the system, and all the heat changes in the system are internal only. When all the changes are internal only, it is known as adiabatic system. There is no exchange of heat with a column of air or a system with the outer atmosphere, and all the heat changes, all the temperature changes are internal only. That is adiabatic. That is known as adiabatic. And when the heat changes are internal only, and where this when there is a lapse raised associated with it, we'll call it as adiabatic lapse rate. In adiabatic lapse rate, there are two types, students. One is wet adiabatic lapse rate and dry adiabatic lapse rate. Student, we have already seen what is lapse rate, normal lapse rate. That is one type of lapse rate. This is second type of lapse rate, adiabatic lapse rate. And in here, we have two types, wet and dry. You must be thinking, sir, what is wet and what is dry then? For better understanding, let's consider we have studied what is normal lapse rate. That is 6 degree per 1000 meter. This is normal condition. And if the air is more drier than this, when see student, wet means a air which is completely saturated. So let's name it wet 100% saturation. What is saturation? Saturation is means nothing but a air is holding as much moisture it can hold. For better simplification, when you when you are full, when your stomach full, and if you not eat anything more than that, that is known as saturation. You have reached a saturation stage now. You cannot eat anything more. Understand? For simplification, let's understand by this. When your stomach full and if you cannot eat anything else, you are fully saturated. When it comes to the air, when the air is holding as much moisture it can hold, that is known as wet. That is 100% saturation. And when it is dry, it is holding less moisture, even lesser than the normal condition. So we name it as dry. So we call it unsaturated. So, student, what happens? Let's understand very briefly here. In wet adiabatic lapse rate, adiabatic, I have already told you, no heat exchange will take place between the system and the outer atmosphere. That is adiabatic. So, what happens in wet adiabatic lapse rate? The air is 100% saturation. So, in adiabatic lapse rate, when the lapse rate is lesser than the normal condition, and the fall here is 4 degrees Celsius 1000 meter. That is for wet adiabatic lapse rate. We name it as WALR. And in dry adiabatic lapse rate, let's name it at DALR. So here the fall is greater than the normal lapse rate because the air is far drier than the normal condition also. So here the fall is greater and it close to 9 degrees Celsius per 1000 meter. So here we can see, students, what happens in the normal condition and when the air is 100% saturated. The temperature is lesser. Why? You may be thinking that, sir, why in the wet adiabatic condition, why the temperature fall is lesser? It is mainly because, student, as we have read here in the latent heat case, that there is an release of latent heat of condensation. So when there is a latent heat of condensation involved, this released heat heats up the system again, because what happens when the column of air, this column of air will rise up in the atmosphere, there will be, what will happen? What will happen then? The, as I told you, the temperature change will be internal. So suppose the temperature will be higher on the ground level. As the column of air move above, the pressure changes, because the pressure falls as you move up in the atmosphere. When the pressure changes, the temperature changes. For when there is a pressure change, there is a temperature change. When there is a temperature change, the volume changes, and that lead to the fall of temperature, which we called it as wet adiabatic lapse rate, and that fall is 4 degrees Celsius. And in dry adiabatic lapse rate condition, student, the moisture is far lesser than the normal lapse rate condition, and here the fall is greater than the normal lapse rate, and the fall is close to 9 degrees Celsius per 1000 meter. Now, student, why we need to study this adiabatic lapse rate and normal lapse rate? That is because in order to understand the stability of an atmosphere, these concepts are important. These concepts are important because by this we will we will come to understand whether an atmosphere or a weather will be stable or unstable, because stability and instability depend upon all these types of lapse rate. And for instability to take place, the first condition is, student, the first condition is there must exist in convection in the system. That is nothing but the rise of air. First thing, for unstable condition to take place, the first condition is there must exist in convection. That is the rise of air. And secondly, it depends upon the stability or instability of the atmosphere, which depends upon the normal lapse rate or the dry adiabatic lapse rate or the wet adiabatic lapse rate. So, student, this was the concept of lapse rate, latent heat, and what are its types and why there exists a lapse rate in the atmosphere. And student, before finishing, let me tell you, we have started with in our on our platform True Tutors. We have started with our personalized mentorship program for geography optionals. You know that, as I told you before starting, that geography is gaining a lot of importance in UPSC, be it UPSC prelims, be it mains, be it your optionals. Even students have started to gain good ranks also in from geography optionals. One of the students scored rank 5 with geography optional lately. Students, there was a time in 2015, back in 2015, where there were rank 1 and were good rankers from geography. Thereafter, geography has has been out of tune for long. Now I have noticed that students have not been able to uh, not been able to score good marks in prelim, just because their geography and environment preparation is quite weak. So here on our platform will be teaching you the very basic essential concepts of geography, which will be important for you to score goods in your, not only in your prelims, also in your mains, and also if you're opting for the geography optional, students. And students, all those for now, students, we are taking up the personalized mentorship program, and all those who are willing to join that personalized mentorship program can visit our channel, can visit our website, that is True Tutors, that is available on the Google. You can simply type down True true-tutors.com, or in case if you wish to contact us, you can connect us on 721 7845312. I will repeat it again. The number is 7217845312, and our website, you can also visit our website, that is true-tutors.com. So I hope so, students, you have understood the today's class which I have taken here. These are all very basic conceptual things which you must know. Geography is gaining importance. You can just go home and check out all these questions where we have which were from geography and environment, and you will come to the understanding that they are asking more than 45 questions from this area. And for all those students who are planning to opt an optional subject now, see student, if you're taking up geography, it will not only help you in prelims, scoring good in prelims, it will help you in other areas of preparation, be it your paper 1 of geography, paper 1 of GS mains, be it paper 2, and even in paper 3, the economics paper, there also geography helps you. And also in essays, now they are asking subjective essays. Geography is a foundational subject, it will help you everywhere in every subject. So, student, all those who are planning to take geography can visit our website. I have mentioned it here. It is true-tutors.com, or you can simply connect us on a mobile number 7217845312. And thank you for joining us. I wish you all a very good day ahead. Thank you so much.